we're going to explore processing data from the Geometrics TVG transverse gradiometer to make a presentation using software available on Geometrics website. The software on Geometrics website will automatically make plates from your interpretation of the data. This video shows the steps necessary to prepare a set for that processing. We start by opening MagPick. And using File, Profiles, Simple Load to load a data set from a TVG magnetometer system. Click Add. We're going to choose a file. Open the file. And now this part of the processing is like normal MagPick processing of standard data sets. We're going to start with Mag1, so we'll get the longitude and latitude for Mag1. Choose Mag1 as our data. Depth will come from depth 1, which is Mag1's depth. Altitude will come from Mag1. On most TVG data sets, Mag1 altimeter is the only altimeter in the system. Check the box to use time. Choose Auto Short UTM if you have geographic locations. Most systems will record with geographic locations. Click OK. Click OK. Now we have set up for the first magnetometer, and we'll click the button Add Channel to add the second magnetometer. We're going to choose Mag2 longitude and latitude. We're going to choose Mag2 as the magnetometer device. Depth 2, and the altitude will be altitude 1. Everything else remains the same. We can say OK. And now we can load the data. The number of lines loaded should be the number of lines surveyed. In this case, 19 profiles were loaded, and the survey did contain 19 lines. File, New, Grid View to display grid locations. File, New, Profile View to display profile information. Most of our work will be done with profile data. Then once a profile window is open, File, Browse to open a file browser so that we can examine and do interpretation on different lines of data as we're displaying now. Once we have the file browser window turned on, we can get ready to start interpretation. Our first step will be to remove DC bias in the traces, and to do that, we're going to click on Edit, Remove DC Offset. We're going to do all profiles global, and the reference channel will be channel 1. We'll say OK. And we can see the amount of offset that's being calculated to be removed from the channel 2 or added to channel 2 to get the DC offset to a minimum. And we can click Save As if we want to make a text file that has this information for future processing or future examination of the data. I'm going to use the default name, dcprotocol.txt, and we will close. And now the green line shows what's going to be our DC offset. We can zoom for a closer look. Right-click, choose Zoom, drag your mouse over an area, and you can see the difference that will be made when we do this calculation. So right-click, redraw. Right-click, select to turn off the zoom tool. And now we can say Edit, Accept, and we're going to say All Profiles, Smooth. OK. And now we have profiles with DC offset removed. And I can browse and look at the various profiles to verify that indeed the DC offset is minimum. Come back to the top, to the first one. The next step is to create a directory or folder for interpretation results. Click on Windows Explorer and choose a location for your interpretation results. In this case, I'm going to put the interpretation in a folder underneath the data folder. There's our interpretation folder. And we can minimize this window. To start, we will select an anomaly and zoom to expand it on the screen. Right-click, zoom, drag to expand it. If you don't like the expansion, right-click, redraw, and either pick a different region or pick a different anomaly to process. In this case, we'll pick another anomaly to process. We'll go from here to here, and we're going to process this small anomaly. Right-click, set marker. Set a marker at one side of the anomaly and another marker on the other side of the anomaly. The markers must each point at the same color trace. If you set a marker on the red trace, the other marker has to be on the red trace. Once you've set the first two markers, we click Inverse, Run. We're going to uncheck the box Use All Default Parameters. Make sure the Use IGRF for Earth Field box is checked. Check the Create Protocol.dat file in the inversion folder and select the inversion folder. Choose an estimate for the source depth. The estimate should be as close as you can guess to the source depth. Once you've done that, you can click OK. And And we can see the results in the dipole spreadsheet. Once we've made all our picks, we can open the dipole sheet. And of course, your dipole sheet will have probably more entries than this one. This is just to explain the procedure. And we're going to choose File, Create Protocol with the sheet open. And we're going to create a full protocol for GMT of profile results. And we can click on the three dotted button next to the output name and choose our own output name and put it in the correct location. In this case, the parent directory of the interpretation directory would be satisfactory. Click OK. We can also cross-reference targets if we have a number of targets. In that case, you check the box for cross-reference targets and choose an appropriate radius. Usually the radius would be approximately the line spacing, or perhaps just a bit more than the line spacing. Okay, and we've exported our two targets. And we've completed the beginning part of making a plate. From this point, we can make a map so that we can have a shaded map on our plates. We can either make a analytic signal map, or we can make a straight magnetic field map. So I'm going to minimize some of these windows. We'll turn off the browse window for the moment. And to make a map, we click on the grid view. Click on the menu item Profiles, choose Interpolate Grid, choose a type of interpolation. In this case, we'll use splines. We're going to use an interval that is approximately 1/2 the line spacing. These lines were about 10 meters. So we're going to choose 5 meter by 5 meter grid interval. Set on data limits, 2,500 iterations, tension 0.25 is good. We're going to filter the data by median value. And now we'll choose an output file. It's a good idea to put the grid interval and other really important information about the grid in the name of the file, especially if you're going to do reiterative work. I'm going to save the file. The format is netcdf, which is somewhat important for us. We'll say OK. We've made a small map. So now we can increase the size of the map. Option size, 3, 4, 6. We'll choose an arbitrary increase in size. see what our picture looks like. If we are satisfied with our picture, then in our picture size, then we can go to operations, increase resolution, and we can choose either bilinear or spline. In this case, I'll choose spline. Here's a map. Now, with increased resolution on the contours, part of the map has no survey lines. In the northwest corner, there's no survey lines, and part of the west side of the map has no survey lines. We can correct this situation by grid clipping. We can clip on profiles. We're going to choose a grid clipping radius slightly larger than the line spacing. We'll choose 12 meters. I say OK. We're going to choose channels 1, 2, since we do have 2 magnetometers. Say OK. And now we have a map with the grid clipped to the area where there are actually profiles. Once the map has been created and satisfactory, we need to export the map using File, Save, Export Grid. We're going to give it a name that says full UTM as part of the name, just to let us know that this is the one that we're going to upload. And we say save, and then we choose NetCDF full UTM from the format window. And we're now finished with preparation of a data set for making plates. Now that we've prepared a set of data, we can open a web browser and we can browse to tvgdata.geometrics.com. And this brings us to the web page that will take us through uploading data to make plates. And there are some instructions available on the website, and there's a link to the latest copy of MagPick, which are sometimes necessary. And on the website is a sample of the type of plate that can be generated automatically from processed TVG data. And finally is a section to fill in your information and point to the files to upload. If you have a company logo, you can browse, find our logo to upload, and click Open. We need to use the inversion protocol. We'll browse. And we'll browse to where we were processing data. and find our protocol file. Usually sensor 1 is starboard or right, and sensor 2 is port or left. If your wiring on your TVG frame has been modified, you can click on a radio button to change these orientation. We can browse for our grid file. And that's the full UTM grid file. And now, for shading, we can provide scale, light source azimuth, and light source elevation, although the default will probably work okay. Finally, you can upload a side scan image if you happen to have a side scan image of the area, and optional color palette, although the TVG full UTM file does contain the color palette. So once we've filled out this online form, we click the Submit button. And we'll get a little message telling us that our files are uploaded and the names of the files. And we can save this page if we want to be reminded, and we will get an email soon telling us that our plates are ready for review.
Contact information can be found on our website at www.geometrics.com, or simply call us at 408-954-0522.